So yeah, today's webinar is a second part of a two-part series. Some of you may have attended the session we did last month on building visualization using Revit and cloud rendering. And today we're going to focus on Revit and 3ds Max. We'll talk about first why you might want to render in 3ds Max in the first place. And then we'll focus on the whole workflow of bringing a file into 3ds Max, linking it in, different rendering engines, talk about lighting and materials, still image output, as well as a little bit on animations. But again, before we begin, we ought to first decide if a rendering in a Revit model in 3ds Max is even necessary. It is possible to get very good results using the rendering capabilities that are included with Revit, and Autodesk Cloud Rendering Service as additional capabilities excuse me, that even 3ds Max cannot offer. We looked at those in last month's webinar on cloud rendering with Autodesk Revit. 3ds Max, however, gives us capabilities that neither Revit or cloud rendering offer. There are more controls for complex lighting conditions, as well as the ability to add visual effects to a scene. And finally, 3ds Max provides animation capabilities that go far beyond the simple walkthroughs that can be created in Revit. Unfortunately, for most Revit users, 3ds Max can be overwhelming and intimidating. It's like a Swiss Army knife with more tools than one could ever seemingly master. On first glance, 3ds Max seems so complex that many users don't even bother to try to explore its capabilities. And those that do frequently wind up going down rabbit holes with unpredictable and frequently less than desirable results. So the key to successful building visualization first in 3ds Max is to focus only on those tools and processes that lend themselves to the task at hand. When you do that, the toolbox suddenly becomes much smaller and more organized. And in this webinar, I will provide an overview of the specific workflow and tools used to create renderings and animations for a building model created in Revit. First, you need to get your Revit model into 3ds Max. There are two ways of doing that: importing the model or linking the model. If you import the model, it is a one-time action. If changes occur to the model in Revit, there is no way to update the existing geometry in 3ds Max. The original geometry has to be removed and the new geometry re-imported. If you link the model and changes occur later in Revit, the model can be updated if desired, but it is not an automatic update. You have complete control in 3ds Max as to when the model gets updated, if at all. Additionally, if the original model is deleted or moved, the geometry in 3ds Max will still be present. It will just not be able to be updated until the link is reestablished. Assuming that the method of choice is linking, which is my recommendation, you have several options for doing so. On the application menu in Revit, you may see an item for suite workflows. These options are meant to automate the process of exporting an FBX file from Revit, which is the standard 3D translation format, and then you can link that into 3ds Max, and it automates that process. I don't like these methods for a variety of reasons. First, linking an FBX file into 3ds Max instead of the Revit file directly can cause complications with texture maps being used for the materials on the Revit geometry. Second, each one of these methods causes a new session of 3ds Max to be launched and a new scene created. You cannot use these methods to link into an existing 3ds Max scene or a currently running session of 3ds Max. On the other hand, on the application menu in 3ds Max, you will find the option to link a Revit file directly or an FBX file that was previously exported from Revit. Again, I prefer to link Revit files directly in most cases because it makes the management of texture maps associated with the materials in the Revit model much easier than using the FBX format. And while you can access the File Link Manager in 3ds Max from the application menu, I usually go to the Utilities command panel to do so. The File Link Manager is not available on the command panel by default. However, it is easy to customize it and add the button. Regardless of the method you choose to link from, the 3ds Max application menu or from the command panel, the result will take you to the same place. When you link Revit models into 3ds Max, there are several presets available to control how your geometry is organized. These can be edited and new presets can be created to accommodate different needs. The most common preset to use is Combined by Revit Material, which makes all objects in Revit that have the same material a single 3ds Max object with the same name as the material assigned to them. For most, but not all situations, this is actually the most efficient way of organizing Revit geometry for visualization in 3ds Max. You will also notice in this image that I have modified my preset so that Revit daylight systems and cameras are not imported with the Revit model. I prefer to create my own cameras in 3ds Max, and daylight systems from Revit may not be the best way to simulate sunlight in 3ds Max, depending upon the rendering engine you choose to use. And more on that in a bit. Using file linking in 3ds Max, you can break the model up into multiple links so that if you make a change in the model, you only need to reload the link that pertains to the view in the geometry it is visible in, rather than reloading the entire model. Additionally, you may want some geometry organized differently. For example, if there are walls that you want to apply different materials to explore them as accent walls, you can link those walls in separately from the rest of the walls with a preset that does not combine elements. That allows you to select them individually for unique material assignments in 3ds Max. To break the model up into multiple links, first in Revit, create dedicated 3D views for use in 3ds Max. In each view, make sure only the objects you want imported with that link are visible. When you choose to link a Revit model from the File Link Manager, you will be given a list of views in the Revit model to choose from. Only the objects visible in the view will be included with the link. When finished, you will have a list of links, all from the same Revit project, but each corresponding to a different view. As an additional organizational strategy, if you like, you can rename each link's layer in the 3ds Max Layer Explorer as it comes in to correspond to the name of the view, making it easier to control visibility and object selection. Once you've linked your geometry into the 3ds Max scene, the very next thing you need to do, if you haven't already, is to set the rendering engine in the Render Setup dialog box. The rendering engine will determine what types of options you have for lighting and materials. There are two rendering engines that are typically used with Revit models, NVIDIA Mental Ray and the newer Advanced Ray Trace or ARC renderer. The NVIDIA Mental Ray engine was the standard rendering engine with Revit 2016 and prior versions back to around version 2010 or maybe even 2009. With Revit 2017, the NVIDIA Mental Ray engine is no longer available in Revit, as it has been replaced with the ARC renderer. Mental Ray is still available in 3ds Max, however, and all Revit materials and lights are fully compatible with it. While the Mental Ray engine is much more complex and slower in general than the ARC renderer, it does provide more lighting controls for scenes with complex lighting scenarios. It also supports special camera effects, while the ARC renderer does not. The ARC renderer, again, is now the rendering engine included with Revit and is also available in 3ds Max. It is also compatible with Mental Ray materials and lighting. It is easier to configure than the NVIDIA Mental Ray engine, and in my experience is usually faster, sometimes significantly so. Because the ARC renderer is easier to configure and is usually faster than the Mental Ray engine, I usually consider it my default rendering engine of choice. However, there are times when the Mental Ray engine is still more appropriate to use. If you need to render a scene like one of these, where there is a large amount of exterior light illuminating an interior scene, use the Mental Ray engine, as it has more controls for global illumination, which is what controls the light bounces or radiosity, as the exterior light strikes surfaces on the interior of the building. While the ARC renderer does perform radiosity, there are no controls to adjust its quality or to magnify its effects, which is usually something you need to do for these types of scenes. Additionally, you can use a Mental Ray sky portal, which allows you to increase the intensity of the exterior light coming into the space. If you need to use special effects, such as lens effects or camera effects, you need to use the Mental Ray engine, as the ARC renderer has no support for those types of objects. In the image on the top right, glow and streak lens effects have been applied to some of the exterior lights to enhance the night scene. In the image on the bottom right, a depth of field effect has been added to the camera, which allows you to draw focus to a specific point in the scene. Notice that the foreground is blurred and the background outside of the room is also slightly blurred, but the table and chairs are in tight focus. There are other rendering engines available with 3ds Max, however they are not usually recommended for use with Revit building models. The scanline render is an old legacy renderer that originated in the days of 3D Studio, a DOS-based rendering program that was the precursor to 3ds Max. The scanline renderer has no support for the mental ray photometric lights or mental ray materials. The NVIDIA iRay renderer, while fully supportive of photometric lights and mental ray materials, and an excellent rendering engine, has very stringent hardware requirements. Unless you have a computer that is specifically tuned for rendering with a very high-end graphics card and lots of graphics memory and multiple cores on your CPU, performance will be substandard at best. There are also third-party renderers available that you can purchase for 3ds Max. Regardless of the rendering engine you choose to use, the majority of time spent in most of your scenes will be working with lighting. This includes light sources such as sunlight and daylight systems, as well as artificial light sources included with the linked Revit geometry or 3ds Max photometric lights. It is also necessary to establish your exposure, much like setting exposure for a camera. And finally, depending upon the scene, you may need to work with mental ray global illumination settings. Exterior lighting comes in two flavors. If you're using the mental ray renderer, use the daylight system tool found on the Systems tab of the Create command panel. Optionally, you can include daylight systems in your Revit link preset. The sun settings of the view that you link into 3ds Max will automatically create a daylight system in your scene. However, if you are using the art renderer, you should use the sun positioner instead. And again, that's why I usually disable the daylight system being imported with the linked model. Use the sun positioner instead, and this is available from the Lights tab of the Create command panel. Whether you use a daylight system or a sun positioner, the process of creating them is virtually identical. When placing artificial lights in 3ds Max, make sure to use photometric lights, as these are compatible with both the mental ray and art renders. They simulate real-world physical light properties. Lights are included with your Revit geometry or photometric as well. And while there are a myriad of settings for artificial lights, the most important is arguably the light distribution. It is here where you can specify a light as a spotlight, for example, or assign a manufacturer's IES or photometric web file to get physically accurate distribution, intensity, and color. Photometric lights can also be set up initially with templates that simulate common types of lights such as halogen, incandescent, fluorescent, and then adjusted further for more effect. In this example, the same scene is being lit by a light that is set up with a template that simulates a 100-watt incandescent bulb on the left. On the right side, the same scene and the same light is using a template for a fluorescent light. Once you have your exterior and/or artificial lights placed and configured, then you need to establish your exposure. For most scenes, I recommend using physical cameras, which allow you to specify physical camera exposure control in the Environment and Effects dialog box. In this way, each camera controls the exposure for the view it defines. You can have an exterior camera configured for exposure that is appropriate for an exterior view, and at the same time have an interior camera that is configured for an interior view. If you are using a depth of field effect, however, you must use a standard target camera in the mental ray render because the art render doesn't support effects, and those don't have their own exposure settings. So in the case of a target camera, you'll need to set your exposure control in the Environment and Effects dialog to mental ray exposure control, which is a global setting for all views and overrides any settings applied to physical cameras. Whether you use physical camera exposure control or mental ray exposure control, however, the settings are the same. For exterior scenes, you will probably find an exposure value of 12 to 14 is appropriate. For interior scenes with artificial light only, a value of 5 or 6 is usually good. When setting exposure control, you can quickly generate a rendered preview of the current view in the Environment and Effects dialog. This preview will dynamically update as you adjust exposure value settings, giving you instant feedback as to the effects of your changes. Again, if you are rendering an interior scene that relies on a large amount of exterior light, especially like the scene pictured here with a large expanse of glass looking to the outside, then you should consider using the mental ray renderer with global illumination enabled. While the art renderer includes global illumination, it is highly automated and does not have the controls that are available with the mental ray renderer. In these images, the rendering on the right is much more well lit from the exterior lighting through the use of global illumination and also with the addition of a mental ray sky portal to amplify the light coming in through the storefront system. At first glance, the myriad of settings and options available for global illumination can appear overwhelming. However, for most scenes, you can simply focus on Final Gather, set to low quality with 2 diffuse bounces. Leave all other settings at their defaults. While you could improve things slightly with higher precision and more bounces and also turning on additional global illumination features, that will also include rendering time dramatically for minimal gain. The Mental Ray Sky Portal, found on the Lights tab of the Create command panel, can be used to amplify the amount of exterior light coming through a window or storefront system. And again, this is not supported by the art renderer, so you'll need to use the Mental Ray renderer in order to take advantage of it. Chances are that you will not need to do too much with materials, since the materials in your Revit model are compatible with both the Mental Ray and the art renderer. However, sometimes you will want to explore different material alternatives in 3ds Max without modifying the Revit model. In those cases, you have several options. First, you can choose from a wide variety of existing materials in the Autodesk material library. If you want to create a new material, you can use any of the starter materials available in the Material Map browser, with the exception of the scanline materials. Those are only supported by the default scanline renderer and are not compatible with Mental Ray or Art. If you are using the art renderer in particular and need to create a new material from scratch, the new physical material type is recommended, as it is specifically designed for use with the art renderer. And it does have templates that you can use to get started with specific types of materials like metals and ceramic tile, water, that type of thing. Finally, when it's time to create your final rendering, you need to make sure you have configured your render output properly. First, time output should be set to single in the render setup dialog box for a still image rendering. The other options are for animation sequences, which will contain multiple rendered images. Next, make sure area to render is set to view, as sometimes it will be set to a crop region, blow up, or some other option frequently used during material and lighting configuration for iterative test renders, and will result in an incomplete scene. Most importantly, set your output size. Most importantly, set your output size. I usually go with one of the pre-configured HDTV settings rather than custom. The larger the image, the longer it will take to render, so render your test images using a smaller size, then increase the size for your final output. Note in the image on the right, the option to render to a file is not checked. And this may seem counterintuitive if you're intending to have a JPEG or a PNG file or some other image file as a final result. However, I recommend that you do not render directly to a file for still images, even with your final rendered image. Instead, make sure the render destination is set to the render frame window, which is usually the default. When you render to the render frame window, you can save your image from that location. Usually you'll want to view that final rendering at the final size and final quality before committing to a file. And this way you can view the image, and if you like it, you can save it immediately without having to re-render to a file. You can also use the RAM player to load the last rendered image into either Channel A or Channel B, and if desired, you can save from the RAM player as well. So let's review the process for rendering a still image for a Revit model in 3ds Max. First, link the Revit model into your scene using the appropriate preset. Don't forget to break the model up into multiple links if it's very large. Choose your renderer before doing anything else. I recommend the art renderer except those cases where you need the additional global illumination or effects support that Mental Ray offers. I usually create at least one camera early in the process, although that can wait until later if desired. If I'm not using any special lens or depth of field effects, I use physical cameras for more flexibility with my exposure settings. If you're using exterior lighting, create your sunlight system or daylight system, again depending on which renderer you have chosen to use. Create any necessary artificial lighting, if any is needed, in addition to what is included with the Revit model. Set your exposure and render a preview image in the Environment and Effects dialog. Remember to use physical camera exposure control for physical cameras, Mental Ray exposure control for target cameras. Set your render output parameters, in particular the area to render and the image size and resolution. Generate a test rendering. You should do this to a smaller size than your final rendering so that it won't take as long. Make any necessary adjustments to lighting and materials. Again, testing your rendering. And then finally, reset your render output to the final desired size and resolution and render to the render frame window. If the final image looks good, save it to an image file from either the rendered frame window or the RAM player. So in addition to the additional capabilities that 3ds Max provides for still images, it also allows for the creation of high-quality animations. 3ds Max animations are centered around the concept of keyframes. Whenever an object is animated, its contextual properties, position, rotation, scale, etc., are captured at critical moments in time, and transitions between those conditions are interpolated by the software to create the animation effects. Because keyframes are tied to specific moments in time, 3ds Max includes an animation time slider which will be located at the bottom of the 3ds Max screen. And it'll provide a graphic display of every critical animation key and its position in the time frame of the animation sequence. The default length of an animation sequence, which is shown here, is 101 frames. One of the first steps in creating an animation sequence is to determine the length of the sequence, the frame rate, and based on the total number of frames necessary, and then to establish those settings using the time configuration controls. And those are located at the bottom right corner of the 3ds Max screen. This will cause the animation time slider, again, which runs along the bottom of the screen, to update to the number of frames. In this image, a 10-second animation is planned with a 30 frames per second frame rate, which is fairly typical for computer playback. The resulting frame count, therefore, is established in the time configuration dialog at 300 frames, overriding the default, which again is 101 frames. Once you've got your time configured, then you can go ahead and animate your objects. And to animate an object using keyframe animation, first turn on Auto Key, which is a button located at the bottom right of the 3ds Max screen. Exercise caution whenever this button is pressed, because anything you do to any object will be added to the animation sequence. You should only have this button pressed when you are actively animating an object. There will be a red border around your 3ds Max screen whenever this button is pressed as a warning indicator. Next, select the object to be animated and move the time slider on the animation bar to the desired point in the animation sequence. Move, rotate, or scale the object as desired, and a key will be placed at that point in the animation sequence. Be sure to turn off the Auto Key button until you are ready to animate something else. Moving the slider back and forth along the animation bar will show the animation effects between the keys. Once the animation sequence has been completed, you'll need to output to a file. I recommend that you do not output directly to an animation format such as ABI, however. Instead, output the entire time sequence to multiple individual image files. 3ds Max will automatically number the file names sequentially when you perform the animation output. I also do not recommend animating a walkthrough as a single animation sequence. Instead, consider rendering multiple smaller sequences instead and use video post, which is included with 3ds Max, to put them all together as a final animation that includes cuts and fades between the various sequences. This way you can re-render a sequence if you don't like it without having to re-render the entire animation. Additionally, it allows for you to handle drastic changes in lighting which cannot always be animated. For example, when you move from the exterior of a building to the interior, the changes to exposure settings and even possibly the change in rendering engines are not possible to animate. By rendering the exterior sequence separately from the interior sequence, you can use a fade transition similar to the way it is done in cinema to give the viewer a sense of the change in location or time. Once the final sequence of images is ready to be saved to an animation format, you can load it into the RAM player, play back for a final check, and if you're happy with the animation, save it to AVI or some other animation playback format from the RAM player. So here's a simple, low-resolution, low-quality animation that is comprised of 3 separate animation sequences combined with video post using cuts and fades to accommodate changes in location and time. And unfortunately, when we're doing something over a GoToWebinar session, sometimes these animations look kind of jerky because of the change in the graphics is too rapid, I think, sometimes for the bandwidth to handle. But hopefully you can see the effect of, you can see those transitions. So let's wrap up by summarizing some key points. While it is possible to obtain very high quality renderings in Revit alone, and the cloud provides capabilities not found even in 3ds Max, 3ds Max provides support for special lens and camera effects and complex lighting not possible with Revit or even with cloud rendering. Using the file linking features of 3ds Max, you can develop strategies for more effective model management as well as flexibility in the creation of 3ds Max geometry from the Revit model. In particular, consider breaking up the model into multiple views that get linked in separately. Budget time for lighting. This includes not only the exterior sunlight settings, but also artificial lights, as well as exposure, and possibly global illumination for more complex lighting scenarios. And while you should not have to spend too much time manipulating materials in 3ds Max, you should become familiar with the 3ds Max material editor and the various material types that are compatible with Mental Ray and the Art Renderer. The typical scene setup begins with linking your file, specifying the rendering engine, camera creation, and light setup, material modification, then a series of test renders until you are satisfied with the result. Remember that you do not need to render directly to a file when you are ready to generate your final image. You can render to the render frame window for a final test, then save from that dialog box directly if you are satisfied with the results. And finally, 3ds Max allows you to create high-quality animations using keyframe animation techniques. Consider the use of video post to break your animation up into smaller sequences for more flexibility in cinematic transition effects. Finally, if you are interested in learning more, and you are an Autodesk subscription customer, you can view the 90-minute class I taught at Autodesk University last November for free. Simply Google AU Online in your browser. Once you are on the AU Online website, sign in with your Autodesk ID, then search on my name, Matt Dillon. My recent building visualization class will be at the top of the list. You can view the presentation in its entirety, as well as download the supporting handout and PowerPoint presentation. Don't forget that Applied Software has regularly scheduled classes in 3ds Max Fundamentals. Simply go to our website, www.asti.com, and follow the links for training to get a copy of the course syllabus, view the class schedule, and sign up for a class. We can also provide custom training for specific workflows, either remotely or on-site. And then again, if you don't have the time, the resources available to do the visualization in-house, Applied Software does now have visualization services that offer everything from still image renderings to animations and virtual reality, and we can even perform the modeling for you if necessary. We can do comparative renderings, which is a very common use for animations, and we can also render different environmental conditions. And if you need any more information on this, you can email either visualizations@asti.com, or you can email the Senior Project Manager, Michael Zevelt, at z@asti.com, or you can call the number listed, or again, just visit our website, www.asti.com, and follow the links for visualization services. And with that, we'll open it up with questions. Christian, do we have any questions that need to be answered?
I do not see any yet.
Okay, so you can use the chat window to ask questions if you need to. Okay, well, so far no questions. If you have questions after the class, feel free to email me directly at mdillon@asti.com. Here's a question: how long does a render take compared to Revit? That's a difficult question to answer because it's kind of an apples and oranges kind of thing. But if you had the exact same rendering in Revit with the exact same settings in Max, so for example, if I was rendering a particular scene in Revit using the art render, and then I rendered that exact same scene in 3ds Max, making no changes to lighting or anything, using the same lights, same camera, with just the default settings of the art render, it's going to take probably, I'm just going to throw a number out there, it's probably going to run maybe 80%. It'll take about 80% of the time that it would take in Revit. It is going to render faster in Max with the same settings, simply because Max is more tuned to rendering than Revit is. But again, there's a lot of variables that come into play there. You know, Max will take more advantage of things like multiple core and multi-threading. It'll take more advantage of, if you've got more graphics memory on your video card, it'll take more advantage of that. So that would decrease the render time as well. On the flip side of that, Max gives you more controls over your lighting than Revit does, and the more you increase the quality of things in Max, the longer the rendering is going to take. So V-Ray, so that's one of the third-party products, and I can't answer that question. Right now, V-Ray is a third-party product. It is not an Autodesk product. I do know of a lot of people using it in 3ds Max, but will it ever be included as a part of 3ds Max? I don't know. That's something that only Autodesk could tell us, and at this point, they probably wouldn't.